In Kansas and Oklahoma this week, the air itself is turning dangerous, thermometers climbing toward 115 degrees, real air temperature, not a heat index inflated for effect. 600 miles north, an entirely different kind of threat is loading up, a corridor of severe thunderstorms, wrapping around that heat, ready to fire off damaging wind, hail, and a tornado risk that's been quietly climbing by the day. Same country, same week, two extremes sitting on opposite ends of the same weather system, and each one is actively making the other worse. That heat dome is functioning exactly like a lid clamped over a pot. Around its edges, the atmosphere is churning, and that churn is precisely where the storms keep firing. While Kansas and Oklahoma bake directly under the lid itself, the northern rim of that same system becomes a factory for severe thunderstorms, stretching from the Dakotas through the upper Midwest and into the Great Lakes. That tension, one region desperate for shade, while another braces for repeated rounds of dangerous storms, is the entire engine behind this pattern. The National Weather Service's Storm Prediction Center has already flagged an elongated corridor running from the northern plains across the upper Midwest and Great Lakes, with the clearest window of concern building through the weekend and into early next week. The main driver is a shift in the winds, both high above the ground and near the surface, both strengthening across the Midwest, the Great Lakes, and the Ohio Valley, as a low-pressure system parked up in Canada pushes a strong flow of air down out of the northwest. When upper-level winds and lower-level winds both crank up together, and you mix in plenty of moisture in an unstable atmosphere, you get a textbook recipe for severe weather. Instability provides the fuel, wind shear, the change in wind speed and direction with height provides the structure, allowing a thunderstorm to organize, tilt, and in the worst cases, rotate. Storms with both ingredients in abundance don't just pop up and fade quietly. They build, organize, and can turn dangerous quickly. The twist that makes this particular pattern worth watching closely is how the wind direction evolves as the weekend progresses. Early on, the flow comes mostly out of the northwest, but as the pattern shifts toward more westerly flow aloft, low-level winds start pulling up from the south instead. When winds near the ground blow from the south, while winds higher up blow from the west, you get exactly the kind of turning in the atmosphere that supercells thrive on, the most organized, most dangerous category of thunderstorm, capable of producing very large hail and strong, long-track tornadoes. If the atmosphere lines up the way current guidance suggests, the window from Sunday into Monday carries a genuine tornado risk across parts of the upper Midwest. Not a guarantee, but a real possibility building several days in advance. Exactly the kind of setup meteorologists don't dismiss just because the worst outcome isn't locked in yet. If you've ever lived through one of these overnight lines of severe storms, the kind that roll through in total darkness with nothing but wind and lightning to mark their passing, drop a comment and share what it was like, because those overnight events tend to be some of the most underestimated hazards in this entire pattern. And a subscribe helps make sure you catch the next update as this setup develops. Now, back to how the rest of this week actually unfolds. The instability numbers feeding into that Sunday setup are notably striking. Forecast models are showing atmospheric energy values reaching into the 4,000 to 5,000 range across parts of Minnesota and Iowa, a tremendous amount of available fuel for storms to draw on. When the atmosphere is primed that heavily and the wind fields line up favorably, thunderstorms don't need much of an excuse to explode into something significant. Current guidance points toward Wisconsin as a likely focus for the most concentrated activity, with an isolated supercell or two possible developing during the early to mid-afternoon across the northern part of the state. As evening approaches, those storms could grow more numerous and eventually merge into what meteorologists call a mesoscale convective system, essentially a coordinated advancing wall of thunderstorms. If that happens, cities including Milwaukee and Grand Rapids, potentially reaching as far as Detroit, could be dealing with severe weather overnight into early Monday, with damaging wind as the primary threat and hail, plus an isolated tornado possible earlier in the cycle. It's worth being honest about the uncertainty involved here because July and August are genuinely among the hardest months of the year to forecast severe weather precisely. So much depends on small-scale atmospheric details that simply don't reveal themselves clearly until the day itself arrives. The potential for Sunday is real, and the ceiling on how significant it could become is high, but the exact outcome remains legitimately uncertain this many days out. It helps to understand exactly what makes a supercell different from an ordinary thunderstorm, since that distinction is doing most of the work behind why Sunday specifically stands out from the rest of the stretch. A typical summer thunderstorm forms, produces its rain and wind, and then collapses under its own weight within roughly half an hour to an hour, its own downdraft eventually choking off the updraft feeding it. A supercell avoids that self-destruction because of a rotating updraft called a mesocyclone, a persistent tilted column of spinning air that keeps the storm's inflow and outflow separated from each other rather than colliding and collapsing the system. That rotation is generated directly by wind shear. The same ingredient building through this weekend's setup. And once a storm develops that rotating structure, it can sustain itself for hours rather than minutes, tracking across considerable distances while continuously regenerating the conditions that allow it to keep producing large hail, damaging wind, and, in the more organized cases, a tornado. That's precisely why forecasters watch wind shear values as closely as they watch raw instability heading into a setup like Sunday's. Instability alone can produce plenty of ordinary, short-lived storms. But it takes that added rotation to turn one into something capable of sustained, organized severe weather. This pattern doesn't wrap up after one big day either, which is really the core of the story here. The same strong northwesterly flow looks set to stay locked in place across the same general regions, keeping multiple rounds of storms firing through the early and middle part of the following week. Monday's focus could shift into Indiana, Ohio, and possibly Illinois, carrying its own risk of significant wind and a tornado or two. Tuesday could reignite further west, back across Iowa, Wisconsin, and Illinois, potentially stretching toward West Virginia. And that's where a second, quieter hazard starts to build, one that doesn't draw the same attention as tornadoes, but can prove just as destructive over time. When several rounds of storms train repeatedly over the same ground day after day, all that accumulated rainfall adds up fast, and flooding becomes a serious concern. Some forecast models are hinting at widespread rainfall totals of 3 to 7 inches across parts of the Ohio Valley by the middle of next week, with isolated spots potentially seeing even more. That's a notable signal specifically because that particular model doesn't typically paint numbers that high across such a broad area, suggesting the atmosphere may be primed to wring out a substantial amount of moisture. Other guidance is more conservative, showing something closer to 1 to 3 inches instead. That disagreement between models matters, and it's exactly why flooding here isn't a locked-in certainty. But when even one reliable model flashes numbers that high over a populated region, it earns close attention, regardless of what the more conservative guidance shows. Meanwhile, on the other half of this split national picture, the heat itself deserves equal attention because it's just as dangerous as anything the storms are capable of producing, even without the dramatic footage that tornadoes generate. High temperatures pushing toward 115 degrees are expected across parts of southern Kansas and northern Oklahoma. This heat isn't a single blistering day that blows through and moves on either. It's expected to strengthen and expand, building into South Dakota and Nebraska with highs well into the triple digits, then intensifying further, heading into the weekend across those same areas. Central Kansas could see highs near 112 degrees, with cities like St. Louis climbing to around 101, and the heat looks stubborn enough to hold on for several more days before finally breaking. Heat consistently ranks among the deadliest forms of extreme weather precisely because it lacks the dramatic visuals of a tornado or hurricane. It simply accumulates quietly and catches people off guard. Checking on elderly neighbors, never leaving anyone or a pet in a parked vehicle, and staying seriously hydrated aren't optional suggestions during a stretch like this one. They're the basic difference between getting through it safely and becoming a statistic. It's worth understanding the heat dome's own mechanics too, since it's the anchor holding this entire pattern in place. A heat dome forms when a large area of high pressure traps a mass of hot air beneath it, functioning much like a lid pressed down over a pot. As air sinks within that high pressure system, it compresses, and compressing air warms further, adding to whatever heat was already building at the surface below. That creates a genuinely self-reinforcing cycle. Sinking air warms the ground, the warmed ground heats the air directly above it, and that heated air helps reinforce the very high pressure system holding the whole pattern in place. Clear skies typically accompany these setups too, since the sinking air suppresses cloud formation, allowing more direct sunlight to reach the surface and compound the heating even further. That combination of reinforcing mechanisms is exactly why heat domes tend to produce disproportionately extreme sustained temperatures compared to an ordinary hot summer stretch, and it's also why they tend to resist breaking down until a genuinely strong weather system, like the cold front expected around the middle of next week, finally arrives with enough force to physically displace them. There's a genuinely striking detail buried in how this entire pattern eventually resolves too, one that captures just how dramatically the atmosphere can swing within a single week. After the heat finally peaks, a strong cold front is expected to sweep through the Midwest and Great Lakes around the middle of next week, and the temperature reversal that follows is dramatic. Low temperatures across Minnesota and Wisconsin could dive back into the 50s and 40s, with a few spots in northern Minnesota potentially dropping into the 30s. Sit with that contrast for a moment. A region that was part of a country baking near 115 degrees just days earlier, suddenly flirting with near freezing overnight lows. That kind of temperature spread across a single nation within a single week is a genuine reminder of exactly how volatile an active weather pattern like this one can become once it locks into a rhythm. It's precisely that collision between extreme heat and an aggressive storm track that's been driving the severe weather throughout this entire stretch. There's one more piece of the national weather picture worth understanding, because it's the part that gets the least attention despite being genuinely unusual for this point in the season. The tropics are unusually quiet right now, particularly across the Atlantic, and there's a specific, well-understood reason behind it. A strong El Niño pattern is currently in place, and El Niño reliably increases wind shear across the Atlantic basin, tearing apart developing tropical systems before they have a real chance to organize into anything significant. That's part of why the Eastern and Central Pacific have stayed considerably more active this year, while the Atlantic sits comparatively calm. On its face, that's genuinely good news for anyone along the U.S. coastline. Fewer storms brewing means fewer immediate coastal threats. But a quiet season isn't automatically the same thing as a safe one. When the Atlantic stays this quiet for this long, the ocean heat energy that would normally be spent powering multiple storms keeps accumulating instead, with nowhere to go. If a storm does eventually manage to break through those hostile shear conditions later in the season, it could tap into that stored energy and intensify rapidly, potentially into a major hurricane. It only takes one storm finding the right opening. That's exactly why experienced forecasters never fully relax their guard, simply because the tropical map looks empty at any given moment. Bringing all of these threads together, what this week actually represents is a country split cleanly in two by one dominant weather feature. That dome of heat over the central and southern plains functions as the anchor for everything else happening around it. Its northern edge is where the jet stream and the broader storm track collide directly with all that accumulated heat and moisture. And that collision zone is exactly what's been producing the daily rounds of severe weather. As the winds shift and strengthen heading into the weekend, the collision zone grows more organized and considerably more dangerous, which is precisely why the Sunday into Monday window stands out from the rest of the stretch. Then, once the broader system finally starts breaking down, the cold front sweeps through, temperatures crash dramatically, and the heavy rain and flooding risk lingers behind it across the Ohio Valley. Through all of it, the tropics stay unusually silent, a quiet that carries its own separate hidden risk further down the road. For anyone in the path of this pattern over the coming days, the practical takeaways are straightforward. Across the Midwest, Great Lakes, and Ohio Valley, treat each afternoon and evening as a window worth staying weather aware for. Keep phone alerts active and know in advance where you take shelter if a warning is issued, especially heading into that Sunday window when tornado potential peaks. Across the central and southern plains, the heat itself is the primary hazard. Plan outdoor activity around the coolest parts of the day. Stay steadily hydrated, and check in on anyone particularly vulnerable to extreme heat. And anywhere the flooding risk materializes into next week, the oldest rule in severe weather safety still applies without exception. Never drive into a flooded roadway, since it takes a remarkably small amount of moving water to sweep a vehicle away. We'll keep tracking how this pattern develops as the picture sharpens over the coming days. Thank you for watching, and I'll see you in the next one.